Okay, so now we're going to talk about doing some calculations with solutions. And you really have to remember that if it's a solution, it's dissolved in something. And if it's aqueous, it's water. So solubility is how much of a substance will dissolve in a given amount of water. We'll get to that later in the next semester. But concentration is usually measured in molarity. And what that means is, this is how you calculate it. It is moles of solute, and that is the thing that we are always concerned about. This liters of solution is mostly water. Okay, other than the fact that it's useful to have the volume, we're not going to use that very often. It's primarily there as a way of determining the moles. By rearranging the equation to find the moles, you take the liters of the solution and you multiply by the molarity. And I am going to say that a lot. Liters times molarity gives you moles. And this is what we want, because we always want to know about how much solute we have. The water is only there as a way of giving us a volume. It's not really that important. So the way you measure the concentration of solutions to calculate this molarity, all you want to do is change to moles. So if you do 34.6 grams of NaCl, 1 mole of NaCl is 58.5. You get 0.591 moles. To find molarity, you take the moles and you divide by the liters. So I'm going to take that 0.591. and I need to divide by the liters. Now, I'm not going to expect you to show me how to calculate liters. At this point, pretty much everything we're going to be doing is either milliliters or liters when it comes to volume. So if you can just remember to take this volume and divide by 1,000, I'm good with that. You know, 4.73 molarity. Done. Capital M is the symbol for molarity. So now, working a little bit backwards, we're trying to find the mass of HCl given a volume and a molarity. So if molarity is moles over liters, I can put in 2.7 molarity equals X moles over 0.05 liters. Remember, you want to divide by 1,000. Don't just put the decimal in the front. When you do that, you're going to find the moles. And that's totally fine if you do that. If you cross multiply, you get 0.135 moles of HCl. And then 1 mole of HCl is 36.5 grams. And you end up with 4.9 grams. Okay, and that's fine. If you want to do it that way, that's great. I'm going to do it a little different way because I'm trying to set you up for doing stoichiometry. So I know that liters times molarity will give me moles. So I'm going to do this in one long conversion. I'm going to start with my liters, and I'm going to multiply by 1 liter on the bottom, 2.7 moles HCl on top. Liters will cancel and I get moles. It's done the same way. If I stopped right now, I'd get that answer. But I'm not going to stop because I want to change from moles into grams. And I still end up with 4.9 grams. And it's a little bit less stopping and calculating, a little bit faster. And it's the way we're going to do stoichiometry. And it works. So I'm going to do it that way. Up to you. So what would the concentration be if you use 2.27 grams of CaCl2 to make 500 milliliter solution? This one, you can't quite do it in the same way. So you have 27 grams. You have to change it to moles. 111.1. Get 0.24 moles of CaCl2. Divide that by the liters. And you get 0.48 molarity CaCl2. So that's the first question. Okay. Then it says, what is the concentration of each ion in the solution? So this goes back to our dissociation reactions. When I take CaCl2 and I put it in water, it turns into calcium ion and 2 chloride ions. And for every 1 mole of calcium chloride, I get 1 mole of calcium and 2 moles of chloride. So if I have 0.24 moles of this, I'm going to get 0.24 moles of calcium ion, but I'm going to get 0.48 moles of chloride. And to find their molarity, all you do is divide by the volume. So this would be 0.48 molarity, and this would be 0.96 molarity. Okay, and so a couple of things. Don't have to do it this way. If you can see the relationship and you can go, oh yeah, look at that. There's 1 calcium, 0.48. There's 2 chlorides, double it. You're done. This is calcium's molarity and this is chlorides. I don't care which way you do it, but I'm showing you the logic behind it. Okay, so for this one, I want you guys to practice it on your own. Start with 45.6 grams of Fe2SO4 and I want you to change from grams to moles, which is 399.9. You divide that out, 0.114 moles, divide by the liters, you get 0.24 molarity. So that's the answer to the first question. Now, when you're asking for the concentration of each ion, so if I want the molarity of the Fe3+ and the molarity of the sulfate, I can do it one of two ways. I can take those 0.114 moles and double it, in which case I would have 0.228 moles for the Fe, and I could triple it for the SO4, in which case I would have 0.342 moles. Divide by the volume of liters, and I'll get the molarity. Or I could say, you know what? I recognize that when this iron 3 sulfate breaks apart, it turns into 2 irons and 3 sulfates. So I'm going to take that 0.24 and I'm just going to double it. And that's the molarity of the iron. And if I do it for this one, I will triple the 0.24 and I'll get 0.72 molarity. And just to prove that this works, check. If I take this 0.342 moles divided by the liters, do I get that? If I take these moles and divide by the liters, do I get that? I don't care which method you use, as long as you are consistent with your math, your chemistry, your logic, whatever you want to call it. Okay? Moles are the single most important thing in chemistry. So now, if we're talking dilution, when it comes to dilution, this is when you take a known concentration of solution with a certain volume and you add more water to it, in particular water, because that's what we're talking about. But the thing is, you're not adding any more solute, you're just adding more solvent. So the moles stay the same. All that changes is the volume, and they're directly proportional. So if I was to calculate the moles of solute before the solution, remember, liters times molarity will give you moles, and moles are always what we're about. The moles before you dilute, if I took the liters before and the molarity before and multiply it, that'd tell me the moles. And then after I dilute it, I'm going to take the liters and the molarity, and that will give me the moles. These two things are equal to each other because all I did was add water. And so I can set those two equations to each other, and I end up with this equation. M1V1 equals M2V2. And a couple things you should know about it is the only thing that regards volume is the volume units must match. They can be milliliters and milliliters, liters and liters. They could even be gallons and gallons. Okay, as long as they're the same units, this equation will work when you dilute stuff because you're not adding any more solute. All you're doing is adding solvent. So, sample problem, what volume of 12 molarity HCl is needed? So that's M1, this is V1, this is V2, and M2. And it's plug and chug. 12x equals 2.5 times 250. X ends up being 52.1 milliliters. Done. So what I would do is I'd measure out 52 milliliters of 12 molarity HCl, and I would add about 198 milliliters of water to it. So the total volume is 250 milliliters. and I've added extra water, so all I did was dilute it down. Okay, and so you can assume the volumes are additive unless they tell you otherwise. You have to assume that. There's no way to know. It's not actually true for some things, but for most things it's pretty close. Okay, so now this one, when I say 18.5 milliliters of the HCl is added to 250, this is V1 and M1. I have 2.3 times 18.5 equals M2. But here's the thing. When I add 250 milliliters of water to the 18.5, the new volume is actually 268.5. Like I said, assume the volumes are additive. It's not really necessarily true all the time, but it's not bad. It's pretty close. So when you end up with this, is 0.185 molarity. Okay, I want to contrast that with the phrasing that's used in the next problem. When it says it is diluted to 250 milliliters, that means they added about 231 milliliters of water. So it's diluted to 250. I set this up. I have 2.3 times 18.5 equals M2, but the final volume is 250. So therefore M2 is 0.17 molarity.